Everyone not in Europe is adding air conditioning. Nobody's fixing the problem. The stories coming out of Europe right now are heartbreaking. People suffering in buildings that weren't built badly. They were just built for a climate that no longer exists at those latitudes. The conversations in North America mostly, why don't they just get air conditioning? But those conversations are missing a piece. This isn't just a European problem. It can happen to any housing stock when the climate moves faster than the code requirements meant to address it. You can always build better than code. Most don't. The difference between Europe and North America right now isn't that we figured something out. It's that we've added mechanical cooling band-aids to buildings that aren't any better designed to adapt to changing climate conditions. We're calling it solved. Air conditioning is great. It can do even more when the building it's working inside of helps it. We all know air conditioning removes heat from air inside of a building. But if the building envelope is continuously letting heat back in through poorly insulated walls, thermal bridges, air leakage, poorly specified windows, the air conditioning is removing heat as fast as the building is letting it back in. You can run your air conditioner harder, you can buy a bigger unit, but the building is going to keep doing what physics says it has to, given the conditions it's built with. The air conditioner that can't keep up isn't failing. The building is asking it to do a job it can't do alone. The buildings in Southern Europe that are struggling right now were designed for climates that averaged meaningfully cooler summers. So they have thick masonry walls designed to store coolness from overnight and release it slowly during the day. Air conditioning in a way. And that worked for centuries. But it doesn't work when the overnight temperatures don't drop low enough to recharge that thermal mass. The building is doing exactly what it was designed to do. The climate it was designed for no longer exists at those latitudes. North American housing has its own version of this. Wood frame homes that don't have the thermal protection that 110 degrees requires. Homes built to energy codes that didn't account for the cooling loads that those buildings would face 20 or 30 years later. You can add air conditioning to any of these buildings. It just moves the problem. It doesn't fix it. So smart people in Europe saw this coming. Passive house started in Germany in the 1990s, precisely because the building science showed it was going to be needed. The standard exists. Most buildings weren't required to meet it. The people suffering in those buildings didn't make bad decisions. They inherited buildings designed for conditions that have changed. A building that supports air conditioning, not one that relies on it, has a well-detailed envelope. Continuous insulation that slows the heat coming in, an air barrier that stops it from moving through the gaps, windows specified for the solar heat gain of the climate, mechanical ventilation that brings in fresh air without dumping the cooling load, and ERV recovers the energy from the air going out before it's gone. Mechanical systems size for the actual load of the building, rather than just the worst day on record. It's not a description of what most buildings have. It's a description of what they need before air conditioning can do its job efficiently. The improvement that changes what air conditioning can accomplish isn't a bigger unit. It's a better building. Air sealing reduces what the unit is fighting. Continuous insulation reduces how fast the heat's coming back in. Right-sized equipment conditions the air properly instead of short cycling through it. Now this requires starting over. It requires understanding which part of the building is making the air conditioning work the hardest and addressing that first. There's one more thing the building envelope does that air conditioning can't. When the grid goes down, which becomes more likely as more air conditioning increases the load on an already stressed system, the envelope is still working. A well-detailed building with good thermal mass, continuous insulation, and a tight air barrier stays cooler longer without power than a leaky building with a stopped air conditioning unit. The envelope performs in July with the grid up, and in July when it isn't. The air conditioning unit only performs when the power is on. If you want help with what that would look like in your house, that conversation is available. The question worth asking before your next air conditioning upgrade isn't which unit to buy. It's what the building is doing to make the current one work so hard. The best investment you can make in your air conditioning is in your building.